Welcome. Today is part 3 of the chapter Binomial Theorem for preparation of JEE Main and Advanced and for different state level joint entrance examination. First problem is problem number 9 of that chapter, and problem is if coefficient of x square and x cube in a plus bx, 3 plus ax to the power 9 be same, then a is options 3 by 4, 4 by 3, 9 by 7 and 7 by 9. In this problem, one binomial is given 3 plus ax to the power 9, a unknown quantity, unknown constant. And given that in that expansion, coefficient of x square and x cube are same, coefficients are same. In that case, to find a, the x square, coefficient of x square, actually it is of the type a plus bx type to the power n. So x to the power 2, I can obtain it in third term and x cube in fourth term. So coefficient of x square is actually 9c third term, so 9c2 into 3 to the power 7 into ax to the power 2, but we want only coefficient, so a to the power 2. Similarly, coefficient of x cube, it is in the fourth term, so it is 9c3, 3 to the power 6 into a to the power 3. So as per our condition, 9c2, 3 to the power 7 into a square is equal to 9c3, 3 to the power 6, a to the power 3. So actually, between a square and a cube, a square will be cancelled, a will be there, and between this and that, 3 will be there. So 9c2 into 3 is equal to 9c3 into a. So that a is equal to 9c2 3 into divided by 9c3. 3 into 9c2 is simply 9 into 8 by factorial 2, that is 2, into 9c3, it is equal to 9 into 8 into 7, and in numerator it is factorial 3, that is 6, 3 into 2 into 1. So 9 and 8 cancels, 2 will be cancelled, so it is 9 by 7. So A is equal to 9 by 7. So option C is correct. Next problem, that is problem number 10. Problem number 10 is if coefficient of x to the power 7 in ax square plus 1 by bx to the power 8, comma, a and b are both positive, is equal to magnitude of x to the power minus 7 in ax minus 1 by bx square to the power 9, oh sorry, to the power 8, same power 8. Then which one is true? Number 1, AB is equal to 1, AB is equal to plus minus 1. Next, a square B is equal to 1. Then AB square is equal to 1. Achha. The problem is, in that expansion, given that, not given that, in that expansion, the coefficient of x to the power 7 and in that expansion, coefficient of x to the power minus 7, their magnitudes are same. And a and b both positive. In that case, which one is true? Achha, now, x coefficient of x to the power 7 to obtain in which term coefficient x to the power 7 exists, we can obtain a very shortcut way. In first term, coefficient of x to the power 16 is there, x to the power 16. After that, 3 power will be decreased. So it is 13, next term 10, next term 7, x to the power 7. So 1, 2, 3, 4, fourth term of that expansion consists of x to the power 7, and it is coefficient is fourth term means 8c3 into a to the power 5, this minus that, into 1 by b to the power 3. Taking a total term, it is actually 8c3 ax square to the power 5 and 1 by b x to the power 3. So here you see it is x to the power 10 minus x to the power 3, that is x to the power 7. It is coefficient of x to the power 7, and we did it in that way without much calculation. Which term contains x to the power 7? Very easily we can calculate. Similarly, in that expansion, x to the power minus 7, in which term it belongs, let us see. First term contains x to the power 8. After that, 1 and 2, 3 will be decreased. Power of x will be decreased 3 term by term. So next one is 5, then 2, then minus 1, then minus 4, then minus 7. So actually it is 1, 2, 3, 4, 5, 6. Sixth term will contain x to the power minus 7. So, and its coefficient is 8c5. 1, 2, 3, 4, 5, 6. Sixth term 8c5 into a to the power 3 into 1 by b to the power 8. I am taking the magnitude because you see this magnitude only. So given that the coefficient of x to the power 7 in that and coefficient of x to the power minus 7 in that, they are equal. So we must have 8c3 a cube by b a to the power 5, sorry, a to the power 5 by b cubed is equal to 8c5 a to the power 3 by b to the power 8. Now a to the power 5, sorry, now 8c5 and 8c3 are equal because 8c5 is equal to 8c, 8 minus 5, 8 minus 5. So it is 3. So this cancels with that. From there, we get, considering these two, we get a square. Considering these two, we get, eh, no, not b to the power 8. It is b to the power 5 because it is 1, 2, 3, 4, 5, 6 term. That is 8c5. So a to the power 8 minus 5, 3 into 1 by b to the power 1 by b to the power 5. 5, okay. That is, we get a square is equal to 1 by b square. So a square, b square is equal to 1. So AB will be equal to not plus minus 1 because A positive, B positive. So a product AB must be positive. So AB is equal to 1 as A positive, B positive. So that AB is equal to 1. So option 1 is correct. Next problem. Problem number 11. And problem number 11 is the coefficient of x to the power minus 10 in x square minus 1 by x cube whole to the power 10 is option minus 210, minus 252, 210 and 610. Now this question is very simple. We have to find coefficient of x to the power minus 10 in that expansion, in that binomial. Like before, first term consists x to the power 20, x squared to the power 10, so x to the power 20. After that, in each successive terms, power of x will be decreased by 2 plus 3, that is 5. So next term will contain x to the power 15, then x to the power 10, x to the power 5, x to the power 0, x to the power minus 5, and x to the power minus 10. Okay, so x to the power minus 10 will be in 1, 2, 3, 4, 5, 6, 7. Seventh term of that will contain x to the power minus 7. Therefore, the required coefficient is seventh term. So it is required coefficient is 10C6, seventh term, so it is 10C6 into coefficient. So 1 to the power something and 1 to the power 4 and minus 1 to the power 6. So positive. So that it is equal to 10C6 factorial 10 by factorial 6 into factorial 4. So that it is equal to 10, 9, 8, 7 into factorial 6, which will be cancelled with that. And here is 4, 3, 2, 1. 4 into 2, 8 cancels. So this cancels 3. 21 into 10. So 210 is answer. So this is answer. Next, problem number 12. Problem number 12 is between, no, not between, let A is equal to 99 to the power 50 plus 100 to the power 50. B is equal to 101 to the power 50. Then which one is true? A is equal to A is equal to 3B. A is equal to B. B is greater than A and A is equal to 2B. Here A is an expression 99 to the power 50 and 100 to the power 60, a very big number. And B 101 to the power 50, it is also a very big number. Then which relation is true? For that purpose, let us start from here. 101 to the power 50. It can be written as 1 plus 100. Oh, I mean 100 plus 1 to the power 50. Expanded binomially. This is equal to 100 to the power 50 plus MC1, that is 50C1, 50 into 100 to the power 49 plus MC2, 50 into 49 by 2 into 100 to the power 48 and so on. If required, I write one or two more terms. And 99 to the power 50 is equal to 100 minus 1 to the power 50 is equal to 100 to the power 50 minus 50C1, that is 50 into 100 to the power 49, then plus 50 into 49 by 2 into 100 to the power 48. Next term will be minus, negative, and so on. Now subtract them, this minus that. So subtracting, we get 101 to the power 50 minus 99 to the power 50 is equal to, this will be cancelled. This, so it will be plus. So 2 into 50 into 100 to the power 49. This will be cancelled. Next term will consist of, is a positive, next term will be a positive quantity plus some positive quantity, because alternate terms will be cancelled, and after that all even position terms are positive. So positive. It is equal to 100. So it is 100. It is 100 to the power 49 plus 1. So 100 to the power 50. So I get plus some positive quantity. So we must have 101 to the power 50 is equal to 100 to the power 50 plus 99 to the power 50 plus some other positive terms. Positive terms. Therefore, we can say that this is greater than that. So, option, this is, B is that, B is this, and this part is A plus something. So, B is greater than A. Next problem. Problem number 13. Problem number 13. And the problem is the coefficient of x to the power 5 in 1 plus x square to the power 5 into 1 plus x to the power 4. We have to find the coefficient of x to the power 5 in that expansion. So it is product term, mind that. Options are 14, 21, 22, 22 and 23. Okay. Here also the problem is very straightforward. We have to find the coefficient of x to the power 5 in that expansion. Here is product of two terms. Now this one is equal to 1 plus x squared to the power 5 into 1 plus x to the power 4. Expand it. It is 1 plus 5c1 means 5 into x square. Then 5c2. 5c2 is 10. 10 into x square plus 5c3. 5c3 is equal to factorial. 5c3 is equal to 5c2. Again 10 into x cube plus 5c4 is 5. 5 into x to the power, oh sorry, this is x square, then to the power 4, because x square to the power 2, next x to the power 6, and so on, into multiplied by 1 plus 4c 1 into x plus 4c2. 4c2 is 4 into 3 by 2, 6 into x square plus next one is 4c3, that is 4 x to the power 3 plus x to the power 4. Now, actually in that expansion there are 6 terms, and in that expansion there are 5 terms. So 6 into 5, that is 30 terms are there. From there, we have to find coefficient of x to the power, coefficient of x to the power 5 is equal to, multiplying this with this, x to the power 5 cannot be obtained. X to the power 5, when I multiply this with that, x to the power 5 will be obtained. It is 20 plus this with x to the power 3, x to the power 5, this with x cube. Oh, sorry. X, it is x square, this is x square, not possible. So actually it is 1 plus x, this is okay. Next term is, it is 4. It is 6. It is 8. That's next. X to the power, when I multiply this with x to the power 1, so I get x to the power 5. It is 40. Multiplying this with, no one is possible to obtain x to the power 5. X square, x 4, 6, 8 and so on. 5, then 10, then expansion is, I think it is 5, 1, 2, 3, 4, 5c3, it is 5c2 is again, ঠিক আছে, and it is 4x, 40. So altogether there are 60. Answer is 60, but 60 is, no option is there. Oh, sorry, very sorry, because answers are given as, options are given as, I have wrongly copied options of another problem. Options are 25, 35, 60 and 80. So 60, option C is correct. Okay, let us stop today, and I thank to all of you. Okay.